So I'm going to be speaking today about a project called ARIES for SEEA, which is intended to speed the production of ecosystem accounts, including not just condition, but also extended services, by putting data and models on the web and making them interoperable. And I'm going to attempt to both give an overview of the project and a quick demonstration in this 20-minute window. So in order to do that, I'm going to start a model run right now, and then we'll return to it after I've given the presentation. And so as a starting point, I'm just showing the ARIES Explorer on the web, which will be hosted on the UN Global Platform early in 2020. For now, this is a more an internal test site, but that's coming soon. And essentially all we do is we go to a part of the world, we specify, in this case, I'll give the example of Hungary. We specify the parameters of the study, the spatial resolution, the years we want to run, and I'll just run this using some defaults to make sure it goes quickly. The types of accounts we want to compile, in this case, I'm going to do an ecosystem condition account and simply choose one indicator, again, just for speed of compilation, leaf area index. And I'm going to run the model, and we can also choose how we report, whether it's for the country as a whole, whether we report for administrative subregions, protected areas, watersheds, etc. But when I click this button, ARIES will access data and models on the web and start to compile accounts. So we'll return to this in a moment, but I wanted to give a quick overview to start and give the system a few minutes to work, given the limited time today. So to jump into my presentation, rather than explicitly global models, I want to frame this more as a way that we connect data and models on the web to make accounting both rapid and customizable and able to do anywhere in the world. My colleagues on this are primarily with the Basque Center for Climate Change in Spain, and we have support from the UN, UNEP, and the European Union to do this work. So essentially, I want to think about where the global community is in compiling accounts. And if we look at the start of ecosystem accounting to 2020, we've certainly made a lot of progress. But have we gotten to this admittedly very high bar of being able to independently compile, use, and institutionalize accounts everywhere, especially within national statistical offices that don't necessarily have geospatial expertise? I would argue that we haven't gotten there, and that based on past work, we can certainly bend this curve upward and start to achieve progress more quickly, but that by using modern data management and artificial intelligence techniques like what we have been developing with ARIES for SEEA, we believe we can get there faster, and that this will be to the benefit of the global community on ecosystem accounting. There's been an assumption that I think that modeling needs to be painstaking and slow, and that's certainly the historical trajectory of it. Our traditional model is that we throw a lot of time and money at a problem. We have GIS analysts who spend lots of time compiling and cleaning and preparing GIS data. We have experts who go through past studies to think about modeling parameters and how best to model certain phenomena. And eventually this data hopefully goes into a data repository. And there's an assumption that you can't have good work be of high quality. However, I think with some of the newer techniques, as I said, for data and model interoperability, we may be leaving this world behind. And what we propose in ARIES is that we could get to a space where we are able to do this work for much less time and money. And the reason it can be done quickly is because past experts have contributed their knowledge and their data to what's called the semantic web, a place where our data and models live on the web, where they can talk to each other, where they can be integrated very easily and quickly. So this essentially means making data fair, which is findable, accessible, interoperable, and reusable. This is a set of standards that was proposed about 4 years ago to make data reusable and interoperable, not just for people to go out and find data, use them, and put them together into new models and new schema, but also for computers to do it in an automated way. And what the research community has found over the years is that we're already doing an okay job of making our data findable and accessible. Open data lets us go to the web and find and access the data we need. for the most part. What we have not been able to do is make our data easily interoperable and reusable, easily able to talk to each other and to be combined into new scientific products like ecosystem accounts. So in order to do this, we use artificial intelligence, and many of you, if you've heard of AI, I'm not going to go too deep into the details, so don't worry about that. But what gets a lot of buzz these days is machine learning, and specifically things like neural networks and deep learning. These are the AI tools that we hear about, and they get a lot of buzz. What I'm going to be talking about is two other AI tools called semantics and machine reasoning, which basically are teaching computers to understand what they're looking at when they're looking at a data set, and to help a computer to decide which data and models to combine under different sets of circumstances. So what ARIES does is it takes that semantics and machine reasoning. The semantics are really a core piece that underlie all other types of artificial intelligence. It's as I said, common labeling that helps a machine understand what a data set is or what a model element might be and how it relates to all other related model elements. And when a computer has this, it can do some pretty powerful things. So we can take algorithms that are designed to do reasoning, which is just decision making. You and I, humans do decision making all the time based on evidence. If we see that it's raining outside, we grab an umbrella or a raincoat. If we see that it's not, we generally don't, unless we know it's going to rain later in the day. So humans do reasoning all the time. The challenge is, can we teach computers how to reason and to pick the right data and models for the right places? We can do that by giving a computer rules about when and where it's best to reuse data, by having semantics, which give consistent labeling to data. With all of that and an ecosystem of open data and models and open source software, we can have fast and fair multidisciplinary modeling, which in this case can support ecosystem accounting for condition and other types of ecosystem accounts. So what we've done with ARIES for SEEA EA is our aim is to support fast and standardized and yet customized accounts creation at the same time. So we want to be able to do accounts anywhere based on global data, but also make it really easy for countries to customize with local data where it's available. And ARIES is a platform that lets us do that. It's also, as you'll see from the example I show at the end of my presentation, fast, and with the web interface, we hope quite easy to learn. It automates the production of maps and accounting tables, and we hope that this will help in the larger efforts to adopt CAE as a statistical standard. In order to do this, we need to be able to have an ecosystem of data and models online and easily plug and play, and where local data can easily substitute for global data. And as you could imagine, one of the things we are very interested in is time series of adequate length, where we can really build those accounting time series. So many of our examples for ecosystem condition go back to the year 2000 and are produced on an annual basis, for instance. The web interface I won't spend much time on, except to say, since you'll see a demo of that, except to say that anyone can download the software tool right now and get started with it. That's a software package that you install on your machine. What I'm showing today is a website you just go to without needing to install any software, and it's all running on the web. And as I mentioned, early 2021, this is going to be available through the UN Global Platform, and we'll be making a number of announcements throughout the SEEA accounting community. So you'll definitely be hearing about that when it goes online. Yes, and there's a as you saw earlier, a way to set up your study and to choose its parameters, which we saw just at the very start of my presentation. ARIES provides transparent data assembly and reporting. So every time a model is computed, there's a workflow that's generated, and you can explore. You can click on each box, and you can see precise algorithms and models were used. So that's all very transparent. And there's a report that's automatically generated each time you run the model as well, which describes the approach, the methods, the results, and any caveats, as well as references. So again, these are ways we're trying to make ARIES as transparent and credible as possible for users, even those not as familiar with geospatial data. Getting into the nuts and bolts of accounting, obviously one of the key things has been for us to find global time series data. And these are some examples of some of the time series data we've incorporated. Our first set of condition accounts, which you're seeing today, focus on forests. So we've included things like drought index, NDVI, LAI, burned area, net primary production, and forest fragmentation. As you can see, those are all time series spanning generally a range of 20 years. There's some other data that we have not included, either because we're not sure about its relevance to forests or because it's not a truly global data set. The list is obviously partial. And if you know of important global time series data sets that we could bring in to ARIES and are interested in doing so, we're very interested in expanding this list of indicators. So again, how do we do this where we can enable ecosystem condition accounts anywhere on Earth? We've developed a set of methods that generally follow the lead of Fernando Santos's team. One of the caveats is that for calculating reference condition, we only have global time series land cover data back to 1992. So we can look at, as reference forests that are within protected areas who've had their cover continually in forests going back to the year 1992. So the steps in order to develop this, first of all, we report on both the condition variables, the index values, the scaled values from 0 to 1, and an aggregated index as well. So of course there are the steps, as I showed, of selecting indicators and also the weightings. The final ARIES interface will let you customize your weightings and choose the indicators you want. ARIES then, as it's doing, is accessing the data on the web. It's identifying the values just within forest ecosystem types. In this case, it's already pre-calculating forest ecosystem types based on the IUCN global ecosystem type models, calculating reference areas, which I've talked about already, comparing each forest pixel to values within reference forests, and classifying the final ecosystem condition by quartile. So those are the steps that are coded into ARIES, but can also be adapted if countries want to select different weightings or different comparative formulas, for instance. This is one quick example, some accounts we compiled for Nepal, looking at NDVI just within forests, cutting that out just for the reference forest, the forest within protected areas that had not changed since 1992, and aggregating all of that into a condition index where we had quartiles. And again, that's done in minutes on a web browser using cloud-based data and can be compiled anywhere on Earth. You can download the tables and the maps quite easily for further analysis. Another example, a little closer to home in Europe, here's an example showing the modeled IUCN global ecosystem types for Romania, the forest leaf area index values, and an exported table showing for different types of forests, both leaf area index and NDVI, an aggregated conditioning index, and a value during an opening and closing year. How do we expand on this? We're just showing examples right now for forests and for the list of condition variables that I showed in that earlier table. We, of course, would like to expand this to cover other types of ecosystems and other indicators. And in order to make our data interoperable and easily ingestible on the web in a way that we're showing, we've taken public data sets. In many cases, we've had to convert daily or monthly remote sensing data to annual values, and depending on the indicator, that could be a sum, a min, a mean, or a max value. We host the data on the web in a way that can be automatically ingested by computers. And for each of those data sets, we write a small code chunk to annotate the data and to make it fair and usable for all. That process is very well worked out. And if we had a larger community effort, for instance, involving some of the people on this call, we could easily expand this to cover more condition variables and ecosystem types. So really, it's about getting the community involved in believing in the value of interoperable data and working toward a common solution like what we've been developing in ARIES. An open question is who's responsible for the updates? If we do this, and if we do this as a larger community, that's great, but there are new data sets that come online. And there are, of course, new year's data that extend the time series forward when the 2020 data are released in the year 2021, for example. And so there's an open question about how we make data fair from the very beginning instead of having to recode and rehost the existing data. And there are definitely methods that are well worked and accepted by the community on how to do this. We just need to understand them as a SEEA EA community and to use methods like these. So this is my final slide, and then we'll jump back to the demo for the last few minutes of the talk that I have. We released the ARIES for SEEA Explorer in late November. It's literally been around for about 2.5 weeks, so it's in a very early alpha release, but we're working through a number of bugs and features right now. The plan is, as I said, in early 2021 to make this available on the UN Global Platform for anyone to use, and also to provide feedback, of course, on any areas that could be improved. During the late winter and spring of 2021, UNSD is going to be leading a conversation with the larger community about how we make data and models interoperable. And this is in line with the Earth Observation for Ecosystem Accounting GEO initiative, has been having a similar discussion about ecosystem accounts ready data. And so there's a couple of different discussion threads moving in this direction about how we make data and models interoperable. We've been working with a number of countries within the ARIES for SEEA pilot team on country examples, how countries can apply this and how they can compare it to their own knowledge about ecosystem condition. For ecosystem condition, we've been working with South Africa. We've been working with a number of other countries on extent and ecosystem service accounts. And we want to provide very clear guidance on how users customize the accounts with national data to add credibility. So that's my presentation. I want to very briefly return to the browser, and as you can see, first of all, I mentioned this being 2.5 weeks old. There are some features that need to be updated, such as the years included automatically. But essentially, we have a leaf area index-based forest condition account compiled, looking at change over time. We can export that to an Excel worksheet. We can, as you see right here, for your own use, and that's valuable for larger tables. This is an extremely simplified example. We have things, and we can show values like forest leaf area index within Hungary. We can also show things like ecosystem types calculated using the IUCN methods. And as I mentioned before, we can show both the data flow, so where data sources are coming from, and let's find a better example here. And also the methods that were used to calculate the different parts of this data flow, and the report, which provides background on it. And this can also be downloaded as a PDF. So that's my presentation, and I'm happy to answer any questions.
That's great, Ken. That was super interesting and inspiring. And I guess I'll get tons of questions coming in the chat any minute now. And I'll start by a question I think everybody is asking is, at what point should countries or even regions get in touch with you to explore how to implement local data? I imagine there's a point of time that would be optimal, maybe not tomorrow, but within what time frame?
Probably this spring. We know that the customizing with local data is going to be critical, especially in Europe, where most of the countries are going to have their own data. If we're applying this in sub-Saharan Africa, for instance, countries are probably going to be happy to use global data. But obviously, for most of the people on this call, you're going to be very keen to integrate local data. And I think this spring is probably the best timeline. But again, we've been partnering with UNSD on this, and they've been so they're going to be helping with outreach to the SEEA EA community, and I would imagine MAIA as a key community will want to be in touch with about that.
That's great. I have another follow-up question. It was very useful to see your FAIR principles and semantics, and I'm guessing that this might become a statistical standard, as I can't recall seeing it explicitly in chapter 5, but it would be part of a guidance on a statistical implementation of a standard. Is that the correct interpretation?
I think it could be. We haven't included it. I've had these discussions with, of course, UNSD and with members of the teams drafting the chapters. So far, it hasn't made it into the SEEA EA manual itself. There is a SEEA EA guidance on biophysical modeling that's being prepared, and FAIR is definitely discussed in there. It's definitely discussed in the GEO EO3A initiative as well, with the ecosystem accounts ready data. So I think it's something that the community is quickly becoming aware of. And that's great, because when we can all start sharing data in this way, you see examples of what we can do here.
Yeah. Excellent. I have a question now online. How open is the ARIES system to add own models, i.e. a model which is being used locally and implemented in Python?
Yeah, great question. So what you're not seeing today, there's actually two sides to the ARIES software. This is the Web Explorer, which, as you can see, is obviously designed to be simple and user-friendly, even for people unfamiliar with GIS data. We also have an ARIES modeler software, which is designed for technical users, and that's designed where people can contribute their own data and models. So if you have a model you prefer for your country or for a particular ecosystem, let's say temperate forests, you could contribute that model, and the idea is to build up this global ecosystem of data and models. That's a more technical approach, obviously. It requires quite a bit of expertise, and unfortunately, with the way, in order to make the data fair, we can't just take a bunch of Python or R-coded models and throw them into a system. There is some work that needs to be done to make them sort of play well within this fair ecosystem. And that's another piece that we're very aware of and going to want to be working on. And we hope ARIES has done an annual training course going back to 2013. That's obviously been on pause with COVID, but I think once we start opening up again, that's going to be one of our focal areas for training, is to get more modelers contributing models to the system.
Excellent, thanks. Another question from me. This is very clearly, limit is probably the wrong word, but at least the scope of the modeling is ecosystem condition. But I imagine there's some other project looking at linking the ecosystem service models to this platform. It's part of the same question as the previous one from Bruno Smets.
Oh yeah,
yeah.
Yeah, I didn't show the other models today because I only had 20 minutes, but actually the ecosystem extend accounts are calculated already in here, because they had to be in order to get us to a condition that would identify them for forest ecosystem types. So we've already coded about a quarter of the IUCN classes for their global ecosystem typology. For ecosystem services, we haven't yet brought them into the Explorer. We're working on the coding for that, but that'll be ready within the next few months as well. And we have a series of ecosystem services where, again, the models are there. They're already linked to the data for about 5 to 8 ecosystem services is probably our initial group that we'll have within this year. So we do have services there, and they'll be included, modeled and reported, just like what I demonstrated today for ecosystem condition.
Very interesting. Here we come, another question from Anand Araza. I was thinking about uncertainty estimates for continuous variables. You showed a table from your run here which had deterministic values. Are you considering including confidence intervals or something of that kind?
We haven't in this initial run. We certainly could. There's a great deal of flexibility with what you build into ARIES, and I guess probably an open question for this community is how complex do we make this interface? Because we've been trying to make this very simple and intuitive. And the more bells and whistles we add to it, there's always this trade-off with user experience and things getting more and more complicated. So on the scientific side, we know we want to produce uncertainty estimates, and we can code those within the modeler. I'm not certain whether or not that would be a good thing to include in an interface like this, but I'd be very interested on people's thoughts.
Okay, thanks. Another question, is the transformation from land cover, and this is from Bruno again, from land cover to IUCN get integrated, and how does this work with local maps instead of generic CCI? I think you're going to have to explain CCI to the audience as well.
Yeah, I can take that. That's CCI is more or less been the global time series data set for land cover. It covers 1992 to 2018 annually, about 20 to 25 land cover classes in 300-meter resolution. So it's a good start, especially for time series land cover data. And so what we've done, as you know, the IUCN ecosystem type information is very new. It was only released last February, and they haven't really produced a methodology for recalculating that. But we have taken their data, and for instance, we can combine land cover with information about climate and topography and other variables to identify, say, different types of deserts, or whether it's floodplain areas and deserts, or hyper-arid deserts or cold deserts. All those can be inferred by combining land cover data with climate data, for instance. So we've built basically what's a lookup table model that codes, I think, 28 of the terrestrial ecosystem types from IUCN, and that runs automatically. And when I talked about semantics, essentially what we do to connect that model to land cover data, whether it's CCI or whether it's local data, is we just annotate them consistently. So two land cover data sets, one might call open water, and one might call open water bodies, just as an example, or one might split out oceans and freshwater. Land cover data sets have all different ways of describing what's in them. And essentially what we need to do is to harmonize them. So we've been doing that. We have the methods to do that. And that's where it takes a little bit of that work to annotate a data set using common language. And once we do that, then the system can automatically pick up and use a local land cover data set instead of CCI.
Great. Thanks. We have a couple more questions. We might have time for both before we leave. From Jessica Andrews, is there a plan to add marine ecosystem types and condition measures?
We would love to. We don't. We're sort of looking for what comes next on this, and particularly if we had partners who are interested in working on marine systems, that would be great. There's certainly no reason we can't. Particularly for the condition indicators, we know a lot of the data that's out there. We just haven't brought it into the system in an interoperable way, and I think we. So I think we need some marine people who are passionate about this idea of interoperable and fair data. And if we had some collaborators who wanted to do that, we'd be very keen to make that happen.
Excellent. It's probably getting a call right after this meeting. One last question from Francois Soulard. Can you mention, how many countries are testing ARIES to measure its use for national official statistics? And do you have, or will you soon have, a document on lessons learned by NSOs?
Probably, again, I would put a document at like the spring or summer of next year window. And we've got, I mentioned South Africa is working with us on testing ecosystem condition. We've been working with the Netherlands on ecosystem extend, and on India with ecosystem services. We've got a number of other folks. We're collaborating with FAO on applying this in Afghanistan and a couple of other countries. And through through a colleague, we've been in conversation with some works that the Swedish Statistical Agency is doing as technical assistance to Bangladesh. So that's a few examples of countries that are starting to pick up on this. And again, the methods that you see here in terms of the Web Explorer is just over 2 weeks old. So so it's very, very new, but we do want to expand that user community, and we're going to be doing that in the months ahead.
Fantastic. Well, just for it to be 2 weeks old, you sound like you've done this every day for the last 2 weeks. You've really got it together, and it's super impressive. I'm afraid we're going to have to leave this topic for now, but we'll come back, have a possibility at the end of the day. And
thanks so much, everyone.
Thanks so much, Ken.